Good morning, everyone. Welcome to Getting Started with Kubernetes training. My name is Denise Shannon. I'm a program manager here at Rancher Labs. With me, I have Rajashree. Rajashree, you want to say hi?
Hey, everyone.
Okay, so today's objectives. Today we're going to go through a technical introduction of Kubernetes using Rancher. We have a couple slides, so not too many, and then we'll basically be doing live demos of what it is to use Rancher and Kubernetes together. In the GoToWebinar on the side, there's a little section called questions. That's where you can ask questions to us. While I'm doing my demo, Rajashree will help answer those questions through the box, and when she goes and starts doing her demo, I'll answer the questions. If it seems like it's a question that would be good for the entire audience, it might be something that I will ask Rajashree to explain in person. Otherwise, look forward to the answers through the question box. And then we'll keep this training open until we answer as many questions as we can, and then anything that we don't, we can follow up later with you. So for the purpose of this training, we're assuming, one, you understand basic Docker concepts. Two, there is a lot more that Rancher has to offer itself, and so we will be doing like I'll do a quick high-level overview of what it is to get started with Rancher, just how to get a Kubernetes environment deployed. But if you want to learn more about Rancher itself, you could go to the Intro to Rancher training. The next one is Thursday, December 14th. So a couple resources before we get started. So there is our doc site. It specifically has a Kubernetes section that talks about, in more detail, about the different configurations that you can do with Kubernetes. It has what the different options are, what does that mean, what your options could be set as. So please go look for there if you have more questions there. We also have our forum site at forums.rancher.com. The community is pretty active, so you can ask questions there. So today's key topics, I'm going to go through setting up Rancher, how to deploy Kubernetes. I'll talk about how you can set up and use kubectl, and then I'll hand it off to Rajashree, and she'll actually go through the concepts of what are pods, deployments, services, config maps, ingresses. She'll be using the setup that I've created for her demo, and just be deploying on that. So a lot of times we get the question of like, why would you use Rancher to deploy Kubernetes? One, for us, I think we call it better together, mostly because it's really easy to deploy. When I show you how to deploy it today, you'll see it's like a one-click deploy. Rancher will manage the upgrades going from the supported versions of Kubernetes that Rancher has, going from one version to another. It's just an easy supported one-click upgrade. And then, we also have like support if you need to. There's just a lot of functionality that we add on top of it that makes it easy to deploy upfront. Okay, so let me get out of my slides. Let's go to what I have set up today. So what I've set up today so far is I basically have 4 hosts in AWS. I actually have set up Rancher OS hosts. You do not need to use Rancher OS hosts. You can use basically any OS that you want. If you want to use it with Rancher, you'll probably want to use something that we more heavily test with in terms of our testing matrix. Common ones that we test with is Ubuntu, RHEL, and Rancher OS. I like to use Rancher OS only because it comes up quickly and it's just easy to use. And what I've done so far is all I've done is I've already started Rancher server, so it's a simple Docker run command where, let's see, in the docs itself, all I've done is basically start this command, where basically it's a Docker run, and then you only want restart unless it's stopped. I've opened up the port 8080, which is where the UI is served at, and then I've actually pulled our most recent stable release, which is Rancher Server Stable. That is actually v1610. And so let's see. I have that up and running here. You can see I just started it, about 12 minutes ago, so I just got it running. And then I have one host for my server, and then I actually have 3 separate hosts here, where all I've done is pre-pull the images that we're going to use for our demo today onto these boxes. so that when we do our deployment, it'll be a little bit faster to get up and running, and we won't be waiting for those images to pull. So let's see. I'm going to minimize these. So now we'll go to the UI itself. You'll see that the first thing you'll do is be asked, if you want to allow Rancher to collect some stats. I highly recommend checking this box. It really helps us understand what the use cases our users are using specifically. We track the different types of deployments that you have. So if you're familiar with Rancher at all, you know that, we're kind of a container. We have different container orchestrations supported. So we have Cattle, which is our own internal one. You can use Kubernetes, which is what this training is about. And then there's like Swarm and Mesos that could also be used. So I'm going to uncheck it because the company doesn't care too much about what I'm using it for. We care more about what our user base is. So here, when you come in, the first thing I'm going to do is actually turn on access control. Basically, what I'm going to do is lock down my setup so that for those who can see my IP here today, you won't be able to actually start fiddling around and doing stuff on my setup. I'm going to turn it on with our local authentication. That's basically creating our own set of database and users inside Rancher itself. I'm going to add Rajashree on it so that when she does her demo, she will be able to access it. I'm going to give her admin access as well. And here you can see, at least for our setup today, I've created basically accounts for me and her to be able to access Rancher itself. So now that access control is set up, I'm going to continue onwards. There's a lot of options here under the admin that we are not going to cover in today's training, but if you want, I highly recommend going to our Intro to Rancher training. So when you start up Rancher, you automatically get started and set up into a default environment. That environment is going to be of type Cattle. So, we are here to do a Kubernetes setup. So what I'm going to do is actually go to our environment templates. So these templates are just default templates that make it easy to start different environments. Before you use any of the default templates, you probably usually want to edit them to make sure that, this is where you can configure them, specifically Kubernetes and all the options that are part of the template. So here you can see with this version of Rancher, we support Kubernetes 1.7.7. In our most recent, our latest release, which is not our stable release, we just released it yesterday to our open source community. That is supporting Kubernetes 1.8, so that's something that you can check out. But usually we have one version of Kubernetes supported for each version of Rancher, and we try to pick up the latest as possible. Here you can see there's a bunch of configuration options available. So the first one is called plane isolation. So this is really important for those who are going to run Kubernetes in production. So basically you can separate it out into 3 planes. There's your data plane, which is where we host etcd. There's our orchestration plane, and that one is where basically all the components that are required to launch and run Kubernetes, that runs in the orchestration host. And then the compute planes is where our kubelets run. That is where when you deploy your applications or services through Rancher, those would go onto those specific hosts specifically for your application. In the documentation, this is a really important concept, I think, for you to make a decision of how you want to set up your Kubernetes. So I just want to point in the docs, you can see here under resiliency planes for Kubernetes. It'll talk about what those planes are. It'll talk about why you would want to do it. It's ideally best if you figure out how you want to set it up before you deploy Kubernetes. It's a little trickier, but it's still possible to just change it later. Usually if you want the separated planes, there's also some requirements of how you need to label these hosts, what we recommend in terms of how many hosts, what size. All that information is located in the docs in here under the Kubernetes tab under resiliency planes. Besides plane isolation, there are different cloud providers that you have the option of. Right now, we support Rancher and AWS in this release. In our most recent release, we also added support for Azure, the cloud provider. So here in the docs itself, you can go to cloud providers, Here it'll cover over what does that mean, like what does it mean if you're using the Rancher cloud provider, what does it mean if you're using AWS and the requirements, and then similarly it'll cover what's required for Azure as well. We also have introduced RBAC support in one of our more recent releases. I can't remember exactly where, but basically with the authentication that you can turn on in Rancher itself, you can then also enable Kubernetes RBAC. Just a couple things to note. So by default, it's turned off, mostly because that allows all your users to get admin access. If you decide to turn it on, you need to be very, you should understand what you're doing before you turn it on. I've had this happen to a couple of users where they've turned it on and didn't understand kind of the repercussions of it, where basically when you enable it by default, no user will now have access to it. You'll now have to create cluster roles and cluster role bindings and apply those to your setup, and then all that information can be located under the Kubernetes RBAC of how you want to set that up. For this demo, I'm going to turn it off so that both of us just get admin rights to, we can all see everything that's being deployed in Kubernetes. If you are behind, like in a big company, you're behind some firewall, you don't have access to the internet or something, so you need access to a private registry, you would want to put your private registry, your information here. You would also, if your private registry needs credentials itself in Rancher itself, you would need to add it to the registries for Rancher itself. This is specifically for this template. Once again, there's more information, as always, on the docs about what does that mean for you, how do you set it up under private registry. Also, if you are, like I said, behind a firewall and you're going to have to use a private registry, even under installing Rancher, this is not Kubernetes specific, this is just Rancher specific. You could go into note our docs under installing Rancher, no internet access. There's like docs of how to use a private registry, how to set it up. So your infrastructure stacks, that's something we'll show in a little bit, how you have to access those. Let's see, so by default, your Sky DNS or your DNS servers only have one pod, so if you want to create more replicas of it, you would scale that up. We have support for a Rancher ingress controller. If you wanted to use like an Nginx ingress controller, you would need to turn the Rancher one off, so you can disable this one here, and then you would be able to, when you create your ingresses, you could use one of the other controllers. By default, we have Kubernetes add-ons. So the add-ons that we're talking about are, and you'll see in the demo, is like we'll automatically deploy Dashboard, Helm, and I think Sky DNS is also under it. Those add-ons are used so that it's easier to use Kubernetes and use it. There's more descriptions about what these add-ons mean and what you can do with them in the docs as well about Helm, Sky DNS. The dashboard, later when we launch it, you'll see that there's a nice, easy-to-click link to launch into Kubernetes, the dashboard, directly. And then usually after that, I don't usually cover anything additional here. These ones are more very specific about services where, let's see, the enable backups and backup retention. This is all related to etcd. There's a little more, these are a little more advanced options I don't usually cover. If you are more familiar with Kubernetes, this is something you can look into where, if you want to start your kubelet with additional flags, you can do that. But those are really the options. As I said, most of these options are covered in the docs. So look at that. Make sure you go and configure it. So you can come and edit your configuration. You can change whatever you want. Click on configure, and then you would want to save your configuration for the default Kubernetes template. If you didn't want to edit your default template, you could always add your own new environment template. So you could create a Kubernetes one. You'd be able to edit the configuration the same way. So you could maybe almost have one that says a Kubernetes one with RBAC enabled. Edit the configuration. Click RBAC as true. Save that configuration and then save that template. So now you have the option of, a Kubernetes where RBAC is off versus a Kubernetes where RBAC is automatically enabled. So these templates are used to when you actually want to start in adding and creating environments. So here we'll add environment. I'm going to use the default Kubernetes one that we just looked at. You give the environment a name. I'm going to add Rajashree as a user so she can have access to this environment when she logs in. And now I'm going to switch to that environment itself. Here you can see as soon as it knows that it's a Kubernetes environment, it's waiting for at least one host. Currently, I have no hosts added to this environment, so I'm going to click on Add Hosts. This is just the host registration URL is just the URL that your host, which will be running a Rancher agent container, where that Rancher agent container can access the Rancher server container. I'm going to save that. Here you have the options to either add our custom host. That's what I'm going to do today because I've pre-pulled those images. We also have support for other machine drivers, and we basically use Docker machine to call and use these other machine drivers. I'm going to just copy the Rancher agent command here. I'm going to find my 3 hosts that I've set up earlier today. Launch those. And close this tab, and here you'll see those hosts start to come up. As these hosts start to come up, they'll automatically start deploying what we call these infrastructure services. Here they're going to deploy network services and IPsec. Those are what we use to create our overlay managed network. So that's how we have our containers' ability to be able to talk across hosts. Health check, that just checks so that if a service is unhealthy, it will be able to report back the status of that service to Rancher. And then you'll have Kubernetes, and here these are all the services that you'll need to get running in order for Kubernetes to get up and running. So once all these services are active and the stack is active, you'll see that here in the Kubernetes dropdown, there's access to dashboard and CLI. I'll click on CLI first. First, you'll see that we automatically provide a kube control shell here, so you can run your kube control commands here directly. You can see that I have my nodes. We won't have any pods running, but you can see in a different namespace, we'll have our add-on pods up and running. Here you can also, this is what Rajashree will probably be doing for her setup, where you can click on Generate Config. It'll create a configuration that you can then use to put in your kube config file so that you can start running kube control commands in your remote shell. You also have access to dashboard, where we'll basically launch that, and it'll direct you into the Kubernetes dashboard that's up and running and be able to see. So here you can see the different namespaces in the kube system. You can see the same pods and deployments that I showed earlier through the kube control shell, what's up and running. So now that we have Kubernetes running, I'm going to hand over the presentation to Rajashree so that she can start going over the details.
Okay, so now that we have the cluster set up, let's start going over a few of the Kubernetes concepts. And I'll have to log in since Denise set up access control, which we recommend you should do. I'm going to go to the K8s environment, the K8s cluster that was created. And before I go ahead with the concepts, I just want to make sure that the kubectl in my shell is configured to be able to talk to this Kubernetes cluster. And for that, I'm going to use this generated kube config and put it in my shell. Okay, so now once that's done, I should be able to run the kubectl commands to be able to access this shell. And I can, as you can see, it lists all the nodes. Now, there are no resources currently created. So let's go ahead and go over some of the Kubernetes resources. So the resources that we are going to cover in this training session are all purely Kubernetes concepts. It's nothing Rancher specific, no custom resources, so they are not going to differ. They are not going to differ no matter in which way you set up your Kubernetes cluster. So the first thing that we'll cover is pod. Now, a pod is the smallest deployable unit in Kubernetes, and it consists of one or more containers that are tightly coupled. Now, Kubernetes supports multiple container runtimes, but Docker is the most commonly known. Each pod gets a unique IP address with which it can be accessed by all other pods and services in the cluster. So like I said, that the containers are tightly coupled. What this means is they'll all get scheduled on the same host. They can also have shared storage volumes, and they have shared network namespace, meaning the containers within the pod will share an IP address and port of that of the pod, which means that they can all be able to find each other via localhost, and so they can talk to each other via localhost. So why would we need such co-located and co-managed containers in a pod? So one such example would be, say if you have an application running, which also needs a helper process running, for example, some log watcher or something. So instead of cramming it all up in a single container, you could have two containers running, one that will run the main application process, and the second that is just a helper process, and you can have them scheduled in a pod. Like one more such example would be if you have an application that constantly needs to make requests to an external database. So instead of having to continuously do service discovery, you can schedule this container in a pod along with another helper container. So this container can directly make requests to localhost, and the helper container can reroute the request of the main container to the external DB. So these are a few use cases of multiple containers in a pod. But the concept of pod can tend to get a little confusing since it can have more than one containers. But apart from the few examples and like similar such use cases that we just discussed, almost all Kubernetes use cases, like most of the Kubernetes use cases include only a single container in a pod. So that's why like one container per pod model is the most commonly known use case, and that is what we are going to use for this training session as well. So let's go ahead and create some pods. Now, for creating the resources, we can use something called we can use a YAML file. For example, this YAML file, and these are also called manifest files. Now, most of the fields in these manifests will be same for all the resources in Kubernetes. For example, you will have to provide the API version and provide the kind of the resource. Over here, we are creating a pod. Now, in metadata, you can provide fields such as what you want the pod to be named like and in what namespace you want it to be created in. If you want to add some labels and provide some other information, there are a few other fields available too. Now, spec is where you can provide an exact description of what you want your pod to look like. So we are creating this pod named shell, in which we want one container running with the name shell, and it will be using this image. Now this like pod won't be doing much. We just want something to be like, something that can let us exec into it and make a few curl requests for the like examples that we are going to cover in this demo. So to create this pod using this manifest, we can use the kubectl create command, to which we can pass this file, and it says that the pod is created. So as soon as the pod gets created, we should be able to see it coming up on one of the hosts. Over here, you can see that the pod shell has been deployed. So now if I do the kubectl get command, it should get listed as running. So the creation of pod is pretty easy. Okay, now let's go ahead and create another pod. And this time we'll just create an Nginx pod running an Nginx container with the Docker Hub image and exposing port 80. Again, I'll use the kubectl create command. So it says that it's created, and when you list it, you can see that it is getting created, and now it's running. So like I said that the pods get their unique IP address. We can find out what the IP address of this pod is. One of the ways to do that is using the kubectl describe command. So let's find out the IP address of, say, the Nginx pod. So what this describe command does is it gives a detailed description of the internal representation of the resource. Like you can see what it tells us, what node it got scheduled to, what IP address it got assigned, and so on. Now, I also said that we can access the pods with their unique IP address from other pods. So let's see how that happens. For this, say I want to just use the IP address of the Nginx pod and see if I can access it from the shell pod that I created first. Now for that, I'm going to use the kubectl exec command, which is very much similar to the docker exec command. Now that I'm in that container, in that pod, yeah, let me see if I can curl. Yeah, so I can curl to that Nginx pod because I can get the Nginx homepage over here, which means I can access other pods using their IP addresses. Now these two pods that we created were provided very few fields in the YAML, but Kubernetes lets us provide a lot more fields in the manifest. For example, if you want to inject some environment variables into the pod, then you can do that via this env field. Or if you want to do any volume mounts, then you can do that as well. Okay, so now that we have covered the concept of a pod, let's go over the next resource called deployment. So the pod that we just discussed is basically an ephemeral entity. So when it gets deployed, it binds to a node. But for some reason, if that node goes down or if the pod goes down, then Kubernetes won't know that it has to reschedule it on another node. And that's why to manage the life cycle of a pod, you would use a deployment to run it. So deployment uses the concept of desired state versus current state. So you can always specify how you want the pods to look like, or how many pods do you want, and the deployment will always make sure that the current state and scale of the pods is same as that of the desired state. And that's why you would never run a pod directly on a cluster. You would always use a deployment to run the pods. Now, in some previous Kubernetes tutorials, you might come across replication controllers, but they are now deprecated, and we instead use deployments. So let's go ahead and create some deployments. For that also, we are going to use these manifest files. And as I said, most of the fields remain same. For example, you have to provide the API version and kind of the resource. Over here, I want to name the deployment Nginx. Now, in the spec replicas, in the spec, there's a field called replicas, which has the value 3. So what this means is, I want 3 replicated pods of this type. So each pod basically will run a single container using the Nginx 113 image, and we are exposing port 80. And just, let's just notice this label app:/Nginx. So this means that all pods that are managed by this deployment will get assigned this label. And we'll see later on how we can make use of this. Suppose we'll create the deployment. For this, again, we are going to use the kubectl create command. It says that the deployment is created. And as you can see, some pods of Nginx have been started. So let's just list the deployment. So it also tells us what the desired number and current is. Now, if I do kubectl get pods, I should have 3 pods from this deployment running, and I do have them. So now that we have 3 pods running, it means that the scale of this deployment is 3. But if I want to, for some reason, change the scale, then I can do that using the kubectl scale command. The way to do it is kubectl scale deployment. Then I want to scale down Nginx, say, to have 2 replicas. So when we do that, we can see that one of the pods is in a terminating state because we want to scale it down. And finally, we have only 2 pods running. Now, we saw the describe command that gives us the detailed description of the resource. There's another command called kubectl edit that will like give us the entire description of the internal representation.
Oh, sorry, real quick. If you scroll up, you can actually click on uncheck show system. It'll hide the system containers, and then you can see just the containers. So it'll be easier to see your containers that you're launching.
Right. So you can see that the containers, or sorry, the pods created by the Nginx deployment, you can see them easily over here on the host. Okay, so now back to the kubectl edit command. As you can see, some of the fields over here are what we had provided in the manifest, and the others are what Kubernetes is telling us what the internal representation of this deployment is. Now, describe lists that, but edit command also provides us an ability to actually make changes to it, to the deployment. So say I want to scale up the deployment back to 3 replicated pods. It says that the deployment has been edited, and let's check if it has created another pod, and it has. So the edit command works too. Now, we saw that how we can use this manifest file to create a deployment, but we also have another command called kubectl run to create the deployment directly. So this is how we'll use it. Let's call it Nginx 2. I'm just going to use the Nginx image and say I only want 2 pods, and it says that it has created a deployment, and it has. You notice the pods immediately coming up on the host. So we have covered the resources of pods and deployments. Now we'll go over another concept called service. So we have seen that pods get assigned a unique IP address, which makes it accessible to other pods and deployments within the cluster. But again, these pods are ephemeral, so their IP address can change. So even if a pod is being managed by deployment, if it goes down for some reason and the deployment brings it up back, it can have a different IP address. So the other pods that need to communicate with this pod need a better way of keeping a track of it. And that's where we use the concept of services. Service provides a DNS entry that can be used to refer to a group of pods. It is similar in functionality to load balancers. It provides a consistent endpoint for the group of pods. So let's go ahead and create a few services. Again, we'll use the manifest file. So the API version guide this service. So in spec, notice this selector field, which is app Nginx. And if you recall, when we were creating that deployment, this is the label that we had provided, app Nginx. So basically what the selector means is the traffic coming to the service will be routed to pods that have this label, which means in the examples that we are using, it will be routed to the pods that are being managed by that deployment, since all of them will have this label. And over here, we can provide some routes such as traffic will be sent from port 8080 to port 80, and then again another one for port 80 to port 80. I'm going to create this service. And it says that the service is created. So let's see if it is running, and it is. Now it gets its own cluster IP address. So now let's make sure that we can make use of this DNS entry created. For that, I'm again going to exec into the first shell pod that I had created. Okay. So now I should be able to curl to this Nginx service, and that should send traffic to the Nginx deployment that we have created, which should give me the Nginx homepage. So now this is just the Kubernetes convention of doing it. So we'll provide the service name first, then the namespace in which it is created, in SPC cluster local. Yeah, sorry, it took some while time there, but you can see that I can call the Nginx homepage. Now let's check if the ports that we had provided are working, and that works too. Okay, so this all works as expected. So the next thing that we'll cover is config map. Config map lets us create files within Kubernetes and expose them to pods. Now, some applications might need certain configuration files at runtime, but we don't want them baked into the container image, because then every time the configuration changes, we'll have to create a new image and then redeploy the pod. So config map helps us in avoiding all of this, and then it lets us change the values in the existing pods. Now, for example, let's take a look at this. The Nginx Docker Hub image, and over here I just wanted to point you to the configuration. Yeah, while running this container, you can provide a volume mount to the configuration file, Nginx configuration file, and this works perfectly fine for a container because we know what host we are scheduling it on. But this won't work that well in case of a pod in Kubernetes cluster, because first of all, we don't know what host the pod will get scheduled on, and so we don't know for sure whether the configuration file is present at this location in whatever host, or whether it is present at all. And that's where we'll use the concept of config maps. So let's take a look at that. This is how we can create a config map. So again, the API version and kind has to be provided. We are naming it testcn, and the data field is what will actually contain the values, like the key value pairs for this config map. So over here, we are just providing key 1 value 1 and key 2 value 2. I'm going to create this. So it says it is created. Now we want to be able to pass this to the pods, and we can do that either via environment variables or via volume mounts. So let's see how we can do it via environment variables. Now over here we are again creating a pod, and we just want to name it this, and it's just creating running a single container with the Ubuntu image. We want to pass it the config map keys like that we created via environment variables, and this is how we'll do it. So the first environment variable, we are calling it primary key, which will take its value from the config map testcn's key named key 1. And similarly, we have the secondary key taking its value from the key 2 from the testcn config map that we created. So let's go ahead and create this pod. And it says that the pod is created. Now I want to check whether the environment variables are exposed, and for that we'll again have to exec into this pod. Right. So now if I list the environment variables, I can find the 2 keys that I had provided via environment variables. Primary key with value 1, because that was the value of the key named key 1, and then the secondary key with value 2. So now let's go over how we can provide these config maps values via volume mounts. So what this does is I'm specifying this volume under which I'm adding this config map testcn, and it's going to be available at this path etc/config within the pod. So let's check it out. But okay, before that, since I'm providing it as a volume, the 2 keys that we had added, the way they will be available within this bound path are in the form of files. So there should be a file named key 1 created and another file named key 2 created, and their values should be like the content of the file should be the values that were assigned to them in the config map. And it says that the pod has been created. So again, to test if it worked, I'm going to exec into the pod. I'm going to directly go to the path that we had provided. And we have those two files created over here. Now, if you want to check the contents of the file, the content of the file key1 is value1 because that's the value that we had assigned to it. And the content of the file key2 is value2. So it worked as expected. Right. And there are a few restrictions on using config maps. So they include that the config map should be created before being referenced by pods. Otherwise, you don't have anything to take the values from. And config maps can only be referenced by pods within the same namespace. Let's go over a proper, like a more in-depth example of what we just covered. For this, we are going to create another Nginx deployment, and this time it will use an Nginx configuration file. And we will expose this file to the deployment via config maps. Now, okay, this is the config file that we'll use, and it does nothing much. It just basically redirects to, like, routes to rancher.com. So we are going to create this deployment. First of all, yeah. So before doing that, I want to just create this config map, which contains the, like, it will contain this default.com, like the file paths of this configuration file as the key, and the value of that key will be the content of the file. So this from file basically just lets us directly pass the file which we want to use to create the config map. And if I do kubectl get, now by using the get command, we can also provide -o YAML, which again gives a detailed description of the resource. And as you can see over here in the data field, we have the file path as the key, and the value is the content of the file that we just checked. Now let's go ahead and create this deployment. So we have this label app proxy over here, and then we are running a container named proxy, which is using the Nginx image. Now we are passing it the proxy CM config map that we just created, and it will be available on this mount path. We chose this path because this is the path that Nginx will by default look into to get the configuration file. Okay, so it says that the deployment is created, and listed. So it is running. Now we are going to create a service for it. Let me show you the service YAML file. So it is using the selector app proxy, which is same as the label that we had assigned on pods within the proxy deployment, and it has this route from port 80 to port 80. So we created this service. You can use such aliases like SPC and PO for the for the resources within Kubernetes. And we have this proxy running. Now to see whether this DNS entry is working, I'm again going to use the exec command and exec into my pod that I created at the very first. So again, the same namespace of the service, SPC cluster local. And so if I do this, oh, there's a typo. Yeah. So when I do this, it should give me nothing but the rancher page, because in the Nginx configuration file, we were just routing to rancher.com. So as you can see, this is the more clear example of using config maps. Now let's cover the next concept called an ingress. We saw that the proxy service got an IP address, and that made it accessible to other pods within the cluster. But we also want to make it available to the outside world. And for that, we can use the resource called ingress. So in ingress, we can, it lets us define a set of rules to route inbound traffic to a cluster service. So basically, it exposes cluster services to the outside world. And yeah, we can define various routing rules based on host and port. So let's look at the ingress YAML. Notice the 3 lines over here, which we can provide to separate resources within a single manifest. So this allows us to declare multiple resources within a single file. And this is our ingress resource that we are creating, named proxy. We are binding it to port 9000. And notice this backend field. So the backend field is a service port combination, and ingress traffic is routed to the endpoints that match this spec.backend field. And we are also creating another ingress resource named Nginx that binds to port 9002, and its backend is Nginx 80. So let's create it. So it has created them. Let's see them. Now it takes some time to get the address assigned to it. So over here we can see that the load balancers for them are getting generated, and we have the address on which these we can access the these proxy and Nginx resources. So let me just take a look at the ingress file. So basically we have the proxy service exposed on port 9, binding to port 9000 and Nginx to 9002. So for the proxy, if I go to this address on port 9000, I should be able to get the Rancher homepage, because that's what we had defined. And for Nginx, if I go to this address on port 9002, I should be able to get the Nginx homepage. So this is, we can see that it's working, and that covers the ingress resource too. And I guess that's it. We have covered all the Kubernetes resources that we wanted to go over in this session.
Great. We didn't get too many questions today, so hopefully you were able to follow along. Usually some common questions we get asked is, one, is this recorded? So we do record it and we do publish it in our YouTube channel. That is available, so later if you are trying to set it up and want to follow along again with her example side by side, you can look forward to that. Another great place for resources is our Slack channel. So the community is really active. We have a couple employees who are really active. There's a Kubernetes specific channel, so if you have any questions when you're getting set up that you might want to ask, you can put it in Slack. Someone will be able to help you. If there's no other questions, I didn't get any questions of stuff we would demo. I see a couple more questions being asked right now just in the chat window. We will probably just turn off the audio in the video for now. I will stop the recording and answer some questions through here. But otherwise, thank you so much. We do hold these monthly, so if you have anything else, just sign up for another session if you want to re-see it. Come to our general rancher training. Otherwise, everyone have a great day. Thanks.